Okay, are we ready to go over this do now? So the first one. So the first one is 5xy minus 15x minus 2yz plus 6z. So you tell me, based on all the sort of tips I have given you throughout this unit, where is your mind going when you see this? Where's the first thing you should be thinking to do? The first thing. Angie? Yeah, count how many factors there are. So I see 1, 2, 3, 4. All right, so I see 4 factors. So now we are in like sort of our grouping box in our head, right? So for 4 factors, what options do we have for grouping? For 4 factors, what options do we have for grouping? Somebody tell me one option. Good, we have a 2 by 2. What's another option? A 1 by 3. And the third option, a 3 by 1. The 1 by 3 and the 3 by 1 means you are grouping together a trinomial that will turn into a perfect square. That is a perfect square trinomial, meaning when you factor it, it's going to be some quantity squared. How come I can immediately take out the 1 by 3 and the 3 by 1? Somebody besides Angie and Bina, somebody new. How come I can take those out? Why? Or immediately I'm like, you know what, this is not a 1 by 3 and this is not a 3 by 1. Lila. Yes, so you're getting ahead of me, you sort of answering my next question, but I'm still in the step before that. How do I know this is not a 1 by 3 or a 3 by 1? Hannah.
There's no squared.
Haley, I called you Hannah. I'm sorry. There's no squared, right? There's nothing squared. So how can something be a perfect square trinomial if there's nothing squared? So right off the bat, I know these options are out. So that gives us a 2 by 2. What is the process for the 2 by 2? We want to try to group things together, right? We want to try to group things together that we can pull out a GCF. And what needs to be left over in the parentheses? The same thing. So you tell me, what did you group together? What did you all group together? Tina? All right, first 2 and second 2. So for the first 2, I'm pulling out a 5x. When I pull out a 5x, I am left with y minus 3. In the second one, what am I pulling out? In the second one, what am I pulling out as the GCF? I want to say Caitlin. Am I right? Yes. I'm so happy. She said a negative 2z, not just a 2z, because we need that y to be positive. So she pulled out a negative 2z. And when she pulled out a negative 2z, she's left with a positive y and a negative 3. All right. In our parentheses, is it the same thing? Yes. Can I pull out a GCF of y minus 3? Absolutely. So now I'm going to pull out a GCF of y minus 3, and we are left with 5x minus 2z. And that is our factored form. Right, that was the first one. How many people got that? Okay, good. So you're all not participating because you're tired, not because you don't know what's going on. That's a good sign. Well, it's not a good sign because it's still a boring class if you don't participate, but it's a good sign you know what's going on. All right, next one. I didn't put all my problems out there. Can somebody tell me what did I write for the next one? Oh, it's right here. Sorry. A raised to the 3n minus 1 plus a to the second. All right, what was my hint to you? It was very similar to the homework problem where we pulled out the variable and exponent that had the numerical exponent, right? Not the variable exponent. So I'm going to go and I'm going to pull a GCF of a to the second. I'm going to pull out a GCF of a to the second. When I pull out a GCF of a to the second, do you all agree we go back and we divide everything by that a to the second? Okay, so now I'm left with, now what do? You keep your base and don't you subtract the exponents? So when you're subtracting the exponents, this is going to be a raised to the 3n minus 1 minus 2. And then what happens with the a's to the seconds? They cross out, but is it 0 there? No, it's not 0 there. What's there? Is it important to have that 1 written there? Absolutely. Lila?
Wouldn't it be better to take a negative a squared?
No. Let's keep going. I'll show you why. So now we're going to have an a squared. And now I have a raised to the 3n minus 3 plus 1. You might think we're done here, but we are not done here. What can we turn this into? What can we turn this into? Somebody show me that you know. What can we turn this into? Sean?
Sum of cubes.
Excellent. This is a sum of cubes. Why? This is a sum of cubes because this can be a, let me make some brackets. This could be a raised to the n minus 1 to the 3rd power. Do we agree? And isn't this just 1 to the 3rd power still just 1? Right, so that's why this is a sum of cubes. My a, I guess we can't use a. Let's use x this time. X will be a to the n minus 1, and our y will be 1. And the format tells us it's going to be x plus y, and then x squared minus xy plus y squared. Usually I use a and b's, but since a is already being used, I just changed my a and b's into x and y's. That's all. Don't forget to keep your GCF in the front. So now we're going to have a raised to the n minus 1 plus 1, and then a to the 2n minus 2 minus a to the n minus 1 times 1, which is just a to the n minus 1, plus 1. Now, I would not distribute in that a to the 2nd, because then you would have to factor it back out. So you do not want to distribute in the a to the 2nd. You leave it just like this. All right. Curious, how many people got that one? Okay. Something like this would be good to know. Just saying. Something like this would be good to know. All right, let's keep going. Number 3. R minus 1 raised to the 5th power plus the quantity of 1 minus r raised to the 3rd power. My mind is going GCF here. Did anybody's mind go GCF sort of for a minute or a second or something, I hope? Right. But the GCF currently isn't going to work because this is r minus 1 and this is 1 minus r. They're so close but not exactly the same. What can I do to make them exactly the same? Does anybody know?
Pull out a negative.
Good, we could pull out a negative. So we could make this r minus 1 to the 5th power, pull out a negative, and then that would be r minus 1 to the 3rd power. Now can I pull out a GCF of r minus 1? Absolutely. So now I'm going to pull out a GCF of r minus 1 to what power? To the 3rd power. And then I'm left with r minus 1 to the 2nd power minus what? Minus 1. You got it. What is this? It is a dot. This is a dot. So in my dots, I'm going to have r minus 1 plus 1, and then r minus 1 minus 1. What happens with the r minus 1 plus 1? The ones cancel. So now what happens with the r minus 1 minus 1? It becomes r minus 2. So now we have an r, and then we have an r minus 1 to the third power, and we have an r minus 2. And those can be written in any order. Those can be written in any order. Also a good one to know. All right, and number 4. 4x squared plus 4xy plus y squared minus c squared plus 4c minus 4. 1, 2, 3, 4, 5, 6. 6 terms. What are our options for 6 terms? What are our options for 6 terms? Complex middle or 3 by 3. Where did your minds go? What were you thinking? Good. Why 3 by 3 and not complex middle? Good. She sees 2 trinomials that she can factor. Another sign is, I'm not saying it's never a complex middle in this scenario, but a good sign that it's going to maybe be a 3 by 3 versus a complex middle is the 3 squareds. Usually there's like 2 squares or 1 squared for the complex middle. This has 3 squareds, which tells you it probably will be the 3 by 3 versus the complex middle. So we're going to group these and group these. So this ends up becoming 2x plus y, the quantity squared. And I'm going to pull out a negative here. When I pull out a negative, I'm left with c squared minus 4c plus 4, which now makes this a perfect square trinomial. So now we are 2x plus y, that quantity squared. And then this becomes c minus 2, that quantity squared. And now have we come down to a dots? We have now come down to a dots. So this is 2x plus y plus c minus 2. And this next one is 2x plus y minus c plus 2. Good. All right, so that was a nice little recap of what we've been doing. A nice little do now refresher, I should say, for what we've been doing up until this point. The very last lesson of this chapter is going to be solving quadratic equations and inequalities. Solving quadratic equations and inequalities. Test, what period is this? Period 4? Test Friday, which means next class is review, test on Friday. So there's a lot of times I don't see you this week because of PSAT and drop and all that stuff. So test will be Friday. All right, let's keep going here. Solving quadratic equations. Okay, when we're solving quadratic equations, we want leading coefficient to be positive. We need it we need it in descending order. Leading coefficient to be positive. Polynomial in descending order. And lastly, the equation to equal 0. So different ways I could ask you to solve a quadratic equation. I can say find the roots. I can say solve for x. Or I can say find the zeros. So all different things, directions I can say. I can say find the roots. I can say solve for x. I could say find the zeros. All of that means solve for x. When we're solving a quadratic equation, so let's say I want to solve for x, and the equation is x squared plus 5x plus 6 equals 0. I know it's been a while since you've been in Algebra 1, but does anybody know what this is if we were to graph it? Definitely not a line. It's a parabola, and we're going to go into the nitty-gritties of parabolas this year in Algebra 2, so if you don't recognize that, that's all right. But basically what this is a parabola. And when we're solving for x, or we're finding the roots, or we're finding the zeros, really what we're doing is I'm giving you a parabola and I'm asking you, where in the graph of this parabola are we going to cross the x-axis? When is y 0, and at what number x? At what number x is y 0? That's really what I'm asking for. Where is this parabola crossing the x-axis? And it's sort of important for you to know that just so you realize what's actually going on in the background here. So how are we going to solve for x? You're first going to factor. So we go ahead and we factor. And this is easy factoring right here. This is plus 3 plus 2 equals 0. And then we will get x equals, then what you do is you set each parenthesis equal to 0. So x plus 3 equals 0, x plus 2 equals 0, and you solve. So x equals negative 3, x equals negative 2. Who remembers this whole process from Algebra 1? Good. We should all remember the process from Algebra 1. All right, what is this saying? This is saying my parabola, the graph of this, is going to cross the x-axis at x equals negative 3. Oh, well, yep, negative 3 and negative 2. So this looks something like that. So essentially what we're doing is we're finding the points where, or the x values of where we're crossing the x-axis for this parabola. That's why they call it zeros, right? That's why when I say find the zeros, well, what's 0? The y is 0, right? That's why we're setting it equal to 0. Right? And roots is just another word for zeros. Yes?
How do you know it's an upwards parabola?
You don't need to know that now. If it's negative in the front, then it's a downwards parabola. But we're going to do parabolas later on, so don't worry about this now. I just wanted you to understand what we were doing. That's why I brought in the graphing. I do not expect you right now to know how to graph these. I just wanted you to understand what we were doing when we were solving. All right, let's keep going. So I want us to find the roots. Okay, when we are finding the roots, okay, it's the same thing as solving for x, right? So we need to factor, but before we can factor, what were my rules? Leading coefficient has to be positive, and it also has to set, it has to be in descending order, and it has to set equal to 0. All right, what are the two things wrong with this? What are the two things wrong? Kaylin.
It's not set to 0.
Good, it's not set to 0, and the leading coefficient on the highest exponent is not positive. So what am I going to do? I'm going to just move the negative 5x cubed over to the other side. So this is going to be a positive 5x cubed minus 20x equals 0. And now we factor. What's the first part of factoring? We always look for what first? First part of factoring is we always look for a GCF. What's our GCF here? 5x, perfect. So when I pull out that 5x, I'm going to get an x squared minus 4 equals 0. Am I done? No, what do we have now? A dot, so we're going to be x plus 2, x minus 2. How many answers am I going to have here? How many answers am I going to have here? I'm going to have 3 answers. Does anybody know from the beginning of the problem how I could have predicted I'd have 3 answers? Remember? Antonio?
X was cubed.
Good, x was cubed. Whenever you have a polynomial, the number of zeros it's going to have is going to be based on the highest exponent, the highest degree in that polynomial. But it doesn't necessarily mean that we're going to have all real number solutions. It doesn't mean that we're necessarily going to have all the real number solutions. It can be that there are imaginary numbers there. So just so you know, but generally speaking, this tells you how many solutions we will have, how many roots. So now we are going to set this equal to 0. So 5x equals 0, x plus 2 is equal to 0, x minus 2 is equal to 0. Right now? No, we're not getting into imaginary for a long time. You're not going to get imaginary solutions. I won't give you imaginary. Okay, so now we're going to divide by 5. So x will equal 0. That's one solution. Then we're going to subtract 2. X will equal negative 2. And now we're going to add 2. X will equal positive 2. So these are our 3 solutions. This isn't a parabola because it's not squared. This is a different graph. But this graph will cross it at 3 different places. Okay, so now we want to solve for x. So some people might be hesitant to try to break this up, the x minus 7 squared. But really, there's nothing we can do with this at this point because it's equal to 29 minus x. It doesn't equal 0, right? So I'm going to have to FOIL this left side out. We're going to have to FOIL this left side out. And when we FOIL this left side out, we are going to get x squared minus 14x plus 49 equals 29 minus x. What do you think I'm going to recommend we do now? What are you going to do now? Lila, any guesses? What do you think we're going to do now? Yeah, we're going to have to set it equal to 0. So we are going to add the x to the other side, and what else are we going to do? Any other ideas? Subtract 29, because we can't have it equal any number except what? 0. We need it to equal 0. So now we're going to subtract that 29, we're going to add that x, And then we will have x squared minus 13x plus 20 equals 0. Oh, sorry guys, this is wrong. This should have been an x squared because this isn't going to factor. Sorry, the problem I just wrote down right now wasn't going to factor. Let's fix this. So we're still going to do the same process. We will subtract the 29 and add the x squared. So when I add the x squared plus x squared is going to give us 2x squared minus 14x plus 20 equals 0. Some might say start factoring right now, and I'm going to say not yet. Why? What should we do first? Pull out a GCF of 2. So now we are going to be x squared minus 7x plus 10. And we know how to factor this. This will be an x minus 5 and an x minus 2. How many solutions should we have here? Based on the exponent, we should have 2 solutions. Do we agree? Can 2 ever equal 0? No, 2 can never equal 0. We're not solving anything there, so that's out. 2 can never equal 0. That is out. But x minus 5 can equal 0 when x is 5, so that's one solution. And x minus 2 can equal 0 when x is 2. That is our second solution. All right, so I wrote another set of directions, factor then solve. How many solutions should I have here? Good, 4. We should have 4 solutions here. So let's factor. Do we all agree it's going to be x squared and x squared in the first part of each parenthesis? And then what are factors of 100 that add to a negative 29? Adam?
Negative 25.
You got it. Negative 25 and a negative 4. Before we try, well, actually, we can solve this at this point if we wanted to, but I didn't say just solve. What did I say? Factor, then solve. So that means I have to get it down to the lowest factored form. So when it says factor and solve, if you just went straight to solving right now, you'd lose some points because I need it completely factored. So tell me now, what kind of factoring is x squared minus 25 and x squared minus 4? That's. So we are an x plus 5 and x minus 5 and x plus 2 and x minus 2 equals 0. Now can we solve? Absolutely. I get x is equal to negative 5, x is equal to positive 5. I get x is equal to negative 2, x is equal to 2. If you wanted to write your answers x is equal to plus or minus 5, x is equal to plus or minus 2, you can absolutely do that. You could also write it x is equal to plus or minus 5, comma, plus or minus 2, all in one. As long as you don't put parentheses around it, you're good. Sean?
Do we have to use like the thing with the brackets?
No, the brackets are only for inequalities.
Okay.
So, okay, next one. So now I'm stepping it up just a little bit. I'm going to say solve for x in terms of a. Solve for x in terms of a. And the problem is 36 a to the fourth is equal to 25 a squared x squared minus 4x to the fourth. Do we all agree we need to have this set equal to 0 for us to factor? So what I'm going to do is I'm going to keep 36a to the fourth here, and then I'm going to subtract the 25a squared x squared, and I'm going to add the 4x to the fourth. It really doesn't matter if you wanted to switch the 36a to the fourth and the 4x to the fourth. It doesn't matter which one you put as the leading one. It does not matter which one you put as the leading one. It will all still work out. Is there a GCF here? No. So we need to factor this. Go ahead and try to factor this. Down to just one set of parentheses. Don't go all the way down. Go to just one set of parentheses. So I think I'm going to push our test to, what did I say, it was Friday? So push it to Monday. If I see you Monday, do I see you Monday? Yeah, because we're not going to finish this lesson, and I don't want to rush the next part of the lesson. So we'll push it. factored this and what did you get? Who factored this and what did you get? Haley?
9a squared minus 4a squared.
9a squared minus what?
4.
4x squared maybe?
Oh, sorry. Yeah.
Okay, and then what was the other one?
And then 4a squared minus x.
Perfect. All right, so now we got to this point. We are not done. What is this? This is a dot. Based on our highest exponent, how many solutions should we have? 4. Based on our dots, we should have 4 solutions. So I'm going to go and I'm going to factor this more. So we're going to have 3a plus 2x, 3a minus 2x. Then we're going to have 2a plus x, 2a minus x. All right, so now here's where the wording comes in. And if on the test you ask me about the wording, I won't be able to tell you. It says solve for x in terms of a. What does it say to solve for? Solve for x. That means we need x all by itself and everything else on the other side. That's what it means. But it's telling you in terms of a, meaning you're not going to get a real number solution. You're going to get a variable solution, and that's okay. That's why it says in terms of a, meaning you will get a variable solution, and there's nothing wrong with that. So now I'm going to do 3a plus 2x equals 0. Solve for x. That means x has to end up all by itself. How do I solve for x? I'm going to subtract that 3a over first. So we're going to have 2x is equal to a negative 3a. Still not done solving for x. Divide by 2. So x will equal negative 3a over 2. What do you think the other one's going to be? X will equal positive 3a over 2, right? They're just inverses of each other, those two parentheses. Sean?
Are we solving in terms of a?
No, it says solve for x in terms of a, meaning you're solving for x, but a will be in x's answer. All right, so we have 2 answers so far. We need 4. So now we're going to have 2a plus x equals 0. So now again, we're solving for x in terms of a. So x needs to be the last man standing. Subtract that 2a, x will equal negative 2a. And what do you think the last one will be? Positive 2a. You got it. How many solutions should we have gotten? 4. How many solutions do we have? 1, 2, 3, 4. Oh, this is a good one. This is one that will definitely mess some people up and lose points for silly reasons. Can I tell you what the biggest mistake here would be? Or does anybody know what the biggest mistake here would be? Sean?
Not foiling.
Yes, the biggest mistake here would be x plus 3 equals 7, x minus 3 equals 7. Why? It has to be set to 0. It has to be set to 0. Is 7 0? No. Guys, let me explain to you why it has to be set to 0. Let me explain to you why it has to be set to 0. If I have 2 things that are being multiplied together, let's say I have an m and an n, and they're going to be multiplying to 0, right? Anything times 0 is 0. Do we agree? So if the first parenthesis is 0, is the whole product 0? Yes. If the second parenthesis is 0, is the whole product 0? Yeah. So right now, if I had 2 things equaling 7, the product of them equaling 7, if just my first parenthesis equals 7, does that mean the product's going to be 7? No. Do you now understand why it has to be 0 for it to work out? Right? Because if either one of the parentheses or either one of the factors are 0, then the whole thing becomes 0. That's why we set the parentheses equal to 0. So now this does not work. So Sean was right. We can't just go into solving right now. We need to FOIL this. When we FOIL this, do we agree this is x squared minus 9? The middle terms will cancel. Equals 7. Bring that 7 over to set it equal to 0. X squared minus 16 equals 0. This is a dots, right? X minus 4, x plus 4. So now, right, if either one of these parentheses equals 0, won't the whole product be 0? That's why it must equal 0. So now we're going to have x minus 4 equals 0, x plus 4 equals 0, and we get x equals 4, x equals negative 4. All right, this is where we're going to stop.